So now we are moving to the next topic in properties of bulk matter, which is called thermal property. So thermal property is the property which is dependent on heat, right? The word thermal means heat. So what is heat? We know the basic definition of heat, that is, it is a form of energy which gives us the sensation of warmth, right? But what is the source of heat? How heat is practically observed by any particle or any body? For example, if this marker, if I fire it up from bottom, the surface is actually going to melt. What exactly is happening when the heat is provided to this body, or this body is getting warm? See, every energy associates some type of motion. So when heat is given to any body, that energy, that heat energy is actually transformed into kinetic energy of all the atoms and molecules of that body, right? So that energy, that kinetic energy, can be of three types. Heat is giving kinetic energy to the molecules or atoms of the body, and this kinetic energy could be of three types. First one would be translational. Translational means particles are moving from one point to another. Then it could be rotational, that is, particles, because they cannot move from one point to another, so they are rotating about in mean position. Last could be vibrational. Vibrational, that means they can't even go in circular motion, they can't even translate from one part to another, so they just vibrate from about a mean position. So these are not just three types of motion. Actually, the motion in a body due to heat comprises of the combination of these, not just any one, actually combination of these. So particle might go translational as well as rotational, or vibrational as well as translation. It can go any type of thing. So this is the practically what type of motion is associated with particles which are given heat. So if we have to define heat now, I'll define it as heat is the total sum of, or you can say heat is the energy associated with the body, which is total sum of kinetic energy of all the molecules which are undergoing translational, rotational or vibrational motion of a body, right? Now that was heat. So what is the SI unit of heat? Before I move on to next topic, SI unit is joules, we know that. And what is the practical unit of heat, or a CGS unit of heat? That is, CGS or practical unit of heat is calorie. What is calorie? 1 calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. It is the heat required by 1 gram of water to raise its temperature by 1 degree Celsius, and not any other 1 degree Celsius like 3 to 4 degree, no, not 6 to 8. It is precisely from 14.5 degrees Celsius to 15.5 degrees Celsius, because this is the temperature at which the properties of water is most stable, right? You know that water has a dynamic nature, that density of water is maximum at 4 degrees Celsius, so water has anomalous nature, right? So that is the caloric form of heat. Now, heat is measured in, quantitatively, heat is measured in term called temperature. If I say that I have given a lot of heat to this pen, actually the temperature of the pen would tell me how much heat has been provided. So temperature is the measurement of heat. So what is temperature? Temperature is degree of hotness or coldness of a body, right? This is degree of hotness or coldness of a body. Okay, so how do we measure temperature? There are many scales on which we can measure temperature. First of all, is there any device to measure temperature? Yes, the device is called thermometer. Thermometer actually depends on lot of properties. For example, the normal thermometer which we are used to put it on below our tongue in mouth, that was the thermometer which was based upon the expansion in the volume of a liquid based on its temperature. Now these days new type of thermometers have evolved which we just hold for a few minutes and it will give us the temperature, that are resistance based. So that is the thermometer which depends on the change in resistance of a conductor due to change in its temperature. Then there are thermometers which actually depends, the gas based thermometers, on which the measurement is taken on account of change in volume and pressure of a gas due to change in its temperature. So basically many types of thermometers are there in market depending on what type of material they are working upon, right? So the scale on which temperature is marked is basically in degree Celsius, right? That is Celsius scale. So what is degree Celsius? Degree Celsius is a measurement of scale on which we get 0 degrees Celsius, that is freezing point of water at which ice starts forming, 0 degrees Celsius, and 100 degrees Celsius as boiling point of water. So this is 0 degrees Celsius to 100 degrees Celsius, right? This is the basic form of degree Celsius. Another one is Fahrenheit. Fahrenheit scale. Okay, so here the freezing point of water is 32 degree Fahrenheit and the boiling point is 312 degree Fahrenheit. So the difference here in this case, the difference between higher scale to lower scale was 100, whereas in this case the difference is 180. So there is a scale on which there is a formula on which you can do conversion from one unit, that is degree Celsius, to Fahrenheit or Fahrenheit to degree. The formula is represented like this: temperature in Celsius scale minus the lowest part, that is 0, upon the difference between highest and lower values, that is 100, is equal to temperature on Fahrenheit scale minus the lower point of Fahrenheit, that is 30, upon the difference in the Fahrenheit scale, that is 180. This X scale or this formula is applicable on any type of scales. Suppose there is some other scale, X scale. So even for X scales, you can put the same formula, that temperature in X scale minus the lower value of X scale upon the difference in the values of X scale. That will be equal to this, that will be equal to this. So this type of formula is applicable of any type of conversion from one type of temperatures representation to another type of representation. So this one I have explained in terms of Celsius and Fahrenheit. But actually the most commonly used temperature thing is Kelvin. Lord Kelvin reduced that scale, so Kelvin is more practical unit of heat. So this is the third form, Kelvin. So Kelvin based the readings on universal gas law, that is PV is equal to nRT. Alright, here if I draw a diagram between temperature this side, this is right now in degree Celsius, and pressure, keeping rest volume and other thing constants, so the graph came out something like this. It started from here and it got something like this. But if I further produce it on the other side, this was minus 273.15 degrees Celsius. This temperature is called 0 Kelvin or absolute zero. This is the lowest possible temperature for the practical nature of materials. So this is called absolute zero. So we also have another definition for absolute zero. Not just it is minus 273. For the sake of convenience, I am saying 273, though it is 273.15 anyhow. Absolute zero is the temperature at which all molecular motion ceases. Everything stops, right? So now we know that if I have to convert temperature on Kelvin to degree Celsius, what it would be? It would be temperature in degree Celsius is what? 273. I wrote the reverse. It is 273 plus what? The temperature in Celsius scale, or actually I am talking in terms of Kelvin, right? So temperature in Kelvin would be 273 plus temperature in degree Celsius. That means temperature in degree Celsius would be temperature in Kelvin minus 273. So at degree Celsius, yeah, that is the true thing. So these are the three scales on which temperature is basically denoted. Let's move on to what happens when heat is provided to a body.